Today I'm going to combine two sections, 7.4 and 7.5. We are first going to do nth roots and then radical expression operations. We're going to use the square root function to really get down to what the nth root means. So first, square root function looks like this. The part that's often left off of a square root is the 2. So this 2 is here, and it's kind of like when we have a number just raised to the first power. We don't write it, but we know it's there. Same way with the 2 on the square root. We don't necessarily write it, but we know it's there. If we're writing the cubed root, we make the square root sign and we put a 3. The 4th root would be a square root sign with a 4. A 10th root would be a square root sign with a 10, and an nth root, n could be any number. This is the notation that we use. The next few examples are going to tell us how we use this when we have numbers. So it says the inverse of raising a number to the nth power is finding the nth root of the number. So 3 to the 4th can be undone by taking the 4th root. So we have 3 to the 4th, and we do the 4th root of it. That means that these two cancel out, and we are left with 3. I would recommend using your calculator on these when we have numbers, because you can simply do 3 to the 4th, and you get 81. And when you do 81 and you plug into the 4th power, which I'll show you in class more how to do, or you can YouTube it, then you will get back to 3. So when it says an inverse, it essentially means that it undoes it. Whatever we started with, 3, was raised to the 4th, and then we took the 4th root of it, thus undoing the operation. Many times when we use these nth roots, so these roots that have any number on them, we're going to take it back to square roots. If we had the square root of a number, we said we started with the square root of 6. If we squared it, and notice the square root would have the 2 here, we would end up with 6. And you can try this in your calculator if you don't believe me, but it is the inverse operation. It undoes it, so we end up with what is inside. So taking that and relating it back to simplifying a 4th root, if you're simplifying this 4th root and you wanted to just get down to a number, you would take this to the 4th power. And that's how it would be simplified. So notice a few key things on this slide. In order to simplify, these two numbers have to match. Again, here, the 2's not always written here, but we know it's there in order to simplify. And the second part is, once they simplify, we say these go away and we're left with what is inside. And that's where 75 came from. A few key guidelines that we're going to be using. We have the square root of 16. In this section, anytime they give us a square root, we are just guaranteeing that it's going to be positive. We learned in the last section that if you find the square root, for example, we had x squared equals 4, and we took the square root of both sides, then we had to do positive, negative. In this section, they're just telling us, hey, we want the square root of 16. If it doesn't have a sign, it just indicates that it's a positive 4. Anytime we take a square root and we use the positive number, that's what we call a principal square root. On the second example, it tells us this is negative square root of 16. So this indicates that this would be negative 4, because we had to do what was inside the square root first, and then we had to tack on the negative at the end. On the last slide, I do want you to write this down. There was a dog barking in the background. Mr. Crispin's dog is a boxer. Writing this down indicates to me that you did in fact watch the video and take the notes. When simplifying the following examples, we're going to divide these into even and odd roots. When we're looking at the odd roots, we're looking inside the parenthesis. On odd roots, we can have a negative on the inside. The reason being is if you're looking for a third root, you're looking at something that is multiplied by itself 3 times. So if we had the cubed root of negative 27, we could say this is negative 3 times negative 3 times negative 3. This is negative 3 to the third. If we took the cubic root of that, then these would cancel out and you would be left with -3 as your answer. So when looking at the number that is giving you the root, you're always looking inside for a number that multiplies by itself that amount of times. So when you're looking at to the 5th root, you have 32. Think about numbers that can be multiplied by itself 5 different times. If you multiply 2 by itself 5 times, you will get to 32. So 2 to the 5th is the same as 32. These would cancel out and you're left with 2 when simplifying this. So notice for odd roots you can have a negative inside or a positive due to the fact that when you multiply a number like -3 by itself an odd amount of times, you're going to end up with a negative on the inside. You've done even roots before. You know that the square root of 16 is 4. You also know that there can never be a negative under a square root. The same applies for any even root. So you should never have any negatives under an even root for the same reason that you can't have a negative under a square root. I want you to take a few minutes, so go ahead and hit pause and complete these problems prior to completing the next lesson. I will put the solutions up shortly. Hit pause if you didn't. Complete the problems. A few key things to remember. If you're adding or subtracting, you treat the square root like a variable. So you would say this would be 2 plus 4 is 6, square root's of 3. The second example, when you're multiplying, you multiply the outsides, you multiply the insides. When you multiply the outsides, it stays on the outside, right here. And when you multiply the insides together, it stays on the inside, and then we simplify. On the final example, if there's not a number out front, it's an understood 1. So then we just write that 1, and we do the same thing that we did on the previous example. One thing, when we break down square root of 12, we look for a number that is a perfect square. Remember, your perfect square numbers are all the numbers at the bottom of the page. So when we break 12 into 4 times 3, we know that the square root of 4 is 2. It comes out as a 2. It's no longer represented inside. It is represented outside. The 3 stays inside. And then we simplify, and we are completed. Some basic properties that we're just going to review really quickly. The first one is when we have an nth root of two things multiplied together, and the second one is the nth root of two things divided. In previous lessons, we saw this working with the square root. Now we're saying it works for any variable n. If we have two things multiplied together inside an nth root, we can split it up. So we can do the nth root of a, and we multiply that by the nth root of b. The reason we're going to use this is we're going to split things up and we're going to simplify a piece at a time. The second definition that we're going to use is when the nth root of two things divided. What we say is we say the nth root goes at the top and it also goes at the bottom. The reason we're going to do this is because we're going to simplify the top and bottom of these according to the nth power. Remember, these do go the other way as well. So if we start with what I've written, we can also rewrite it in this way. Now to the examples you've all been waiting for. The first one should look very familiar. You should be able to simplify this one very easily. One thing to remember is that there is a plus or minus, so we're going to have to include that in our answer. First one we're dealing with is a square root, so we are looking for things that are squared. So I'm going to write 25 as 5 squared. I'm going to write x to the 4th as x squared squared. And the reason being is when I do the square root of this, these two items will cancel out. So when I simplify this, I'm going to end up with the plus or minus the square root of 5 squared. So I'm going to have, and I'm going to just split it apart for clarification here so that we can really see the simplification more clearly. So we have 5 squared, that is 5. We still have plus or minus. It's 5 times whatever this would be. And if you notice, this is squared and it's a square root. So we know that this can simplify down very easily. These two essentially go away and we're left with x squared. So our final answer is plus or minus 5x squared. The next one is a fifth root. So knowing that it's a fifth root, we want to find things that can be multiplied by itself 5 times. We saw in a previous example that 32 is 2 to the 5th. I still have the negative sign. I still have the fifth root. I also have x to the 15th. When dealing with this x to the 15th, I want to write it as x to the something power to the 5th. The reason being is when we have that 5th root, it will cancel this out and we'll be left with whatever's inside. This number is 3. And the last one is y to the 20th. We're doing something similar with this problem. And we're going to say y to the what times 5 will get us 20. It's y to the 4th. So once we've set it up, the simplification becomes easy. We still have our negative outside, and now we have 2 to the 5th raised to the 5th root. So that's just a 2. It's now represented on the outside. These two go away. We have an x to the 3rd represented on the outside. And since this is a 5th root of a 5th power, we have y to the 4th on the inside. And that is our final solution. On the next example, I'm going to delete the 81. I'm just going to change the problem so that we can focus on the variables. When we have x to the 30th, we want to rewrite this as x to a certain power, and this time we're going to have it raised to a 6th power. So instead of x to the 30th, we're going to write this as x to the 5th to the 6th. And when we have y to the 14th, I'm going to rewrite this as y to the 6th times y to the 6th, and that's all going to be times y squared, because if we add these exponents, we get to 14. The reason I rewrote it like this is because I can take out y to the 6th to the 6th. So when I go to simplify this, I'm looking for groups of 6. Here's a group of 6. These go away, and now I have an x to the 5th on the outside. I also have a y squared. Y squared is not to the 6th, so I'm still going to have a 6th root, and it's going to be y squared. So now I've represented that. Y to the 6th comes out, and that comes out as a y. Y to the 6th root is just a y. It's now represented on the outside. Likewise here. So now I've taken everything, I've represented it on the outside or the inside respectively, and my last step is to simplify to my final answer. The next set of examples is just going to be using our rules. So using our rules, we know that the square root of this can be rewritten as, right now we just want to leave it like this after we have simplified it. I want you to do the next problem on your own for class. We'll talk about it in class. And I'm going to move on to the next example. I'm going to treat it the exact same way I did as the first one, except now I have a 5th root. So I do the 5th root of the top and the 5th root of the bottom, and right now we're going to leave it like this. The next example is one that you should definitely be able to do. You should be able to simplify each case and then get like terms and combine like terms. I also want you to complete this one for next time. The last example that we're going to do is the one that has the 3rd roots. We treat these just like square roots, as in that we multiply what's on the outside and we keep it on the outside. We multiply what's on the inside and we keep it on the inside. So we have 216 into the 3rd on the inside. And then we simplify. So we have an 18 on the outside. We're going to skip over 216. We're going to come back to it. We know that there's probably going to be some kind of number there. Into the 3rd comes out as just an n. We still have this 216 that we're going to deal with. At this point, you're going to want to use your calculator. You're going to say, what are some cubic numbers that can go into 216? I started by saying, let's see what 8 happens. So I know that 8 times 27 is 216. And then I know 27 is 3 to the 3rd. So I'm going to rewrite 216 as 2 to the 3rd times 3 to the 3rd and simplify. Taking the cubic root of both, I end up with nothing under the cubic root, so I don't need to write it. And at this point, I just want to combine like terms and finish the problem to get 108 in. The last two problems I want you to finish on your own. The first one you're going to have to FOIL on, and the second one you're going to have to multiply by the conjugate. So I've already set it up for you. Notice on the first one when you're FOILing, you're also going to simplify. Simplifying might mean simplifying a square root or combining like terms. You might have to do both. I want you to complete both of these problems for class next time.